Every building you have ever walked into began as a drawing on paper. Before a single wall was built or a single beam was placed, an architect used precise measurements, exact proportions, and careful calculations to describe every corner, every distance, and every angle of the structure. The tool that makes all of this possible is the coordinate plane. From calculating exact distances to finding the midpoint of a line segment to understanding the relationship between slopes, the coordinate plane is one of the most powerful problem-solving tools in all of mathematics. Let's put it to work. We will anchor everything to a real-world connection that ties it all together. Blueprint. A scale drawing that represents a real object or space, such as a building or room, using exact measurements and proportions. Blueprints connect coordinate plane skills like distance, midpoint, and slope to real design and planning problems. Every ordered pair on a blueprint represents a precise location, every line segment represents a wall or boundary, and every measurement represents a calculation that must be exactly right. Now let's build our toolkit for working on the coordinate plane, starting with figures we will be measuring. Line segment. A straight path between two endpoints. On the coordinate plane, we use coordinates to precisely calculate the length and midpoint of any line segment. Every side of every polygon on the coordinate plane is a line segment, and it's important to understand how to measure line segments. Vertices. The corner points of a polygon. On the coordinate plane, vertices are identified using ordered pairs, which allows us to calculate side lengths, perimeter, and area of any polygon precisely. Think of vertices as the address of each corner of a shape, giving us the exact coordinates we need to make every calculation. Now let's learn how to measure the distance between any 2 points on the coordinate plane. Distance. The length of the straight path between 2 points. On the coordinate plane, the distance is always measured as a positive value and can be calculated precisely using the distance formula. Whether you are measuring the length of a wall on a blueprint or finding the distance between 2 cities on a map, the concept is exactly the same. Distance formula. A formula used to calculate the exact distance between 2 points on the coordinate plane. It is derived from the Pythagorean Theorem and is written as distance equals the square root of the quantity x sub 2 minus x sub 1 squared plus the quantity y sub 2 minus y sub 1 squared. The difference in the x coordinates and the difference in the y coordinates acts as the legs of the right triangle, and the distance is the hypotenuse. Every time you use the distance formula, you are applying the Pythagorean theorem in disguise. Midpoint. The point that is exactly halfway between 2 endpoints of a line segment. On the coordinate plane, the midpoint is found by averaging the x-coordinates and averaging the y-coordinates of the 2 endpoints. Midpoint equals the quantity x sub 1 plus x sub 2 divided by 2, and the quantity y sub 1 plus y sub 2 divided by 2. Think of the midpoint as the halfway mark of a road trip. If when you know your starting point and your destination, the midpoint tells you exactly where you will be when you are halfway there. With distance and midpoint in hand, let's turn to the third essential measurement of the coordinate plane, slope. Slope. A number that describes how steep a line is and the direction it travels on the coordinate plane. Slope is calculated by dividing the vertical change by the horizontal change between any 2 points on a line. Slope is also known as rise over run, or y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. A positive slope rises from left to right, a negative slope falls from left to right, a zero slope is horizontal, and an undefined slope is vertical. Think of slope as the steepness rating of a hill. A gentle slope is a small number, and a steep slope is a large one. Reciprocal. The number you get when you flip a fraction upside down. For example, the reciprocal of 3/4 is 4/3. In geometry, reciprocals are the key to understanding the relationships between the slopes of perpendicular lines, whose slopes are always negative reciprocals of each other. Now that we understand slope, let's look at how slopes reveal the relationships between lines. Parallel. Two lines that are always the same distance apart and never intersect. On the coordinate plane, we can confirm that two lines are parallel by showing they have exactly the same slope. Just as parallel lines on a road never meet no matter how far they extend, parallel lines on the coordinate plane share identical slopes and will never cross. Intersection. The point where two lines or line segments cross each other on the coordinate plane. The coordinates of the intersection point satisfy the equations of both lines at the same time. Think of an intersection like the crossing point of two streets on a city map. It is the one location that belongs to both streets at once. Slope relationships. The connections between the slopes of parallel and perpendicular lines. Parallel lines always have equal slopes. Perpendicular lines always have slopes that are negative reciprocals of each other, meaning their slopes multiply to equal -1. These two relationships are powerful shortcuts. If you know the slope of one line, you can immediately write the slope of any line parallel or perpendicular to it without doing any calculations.